Hello, this is Moles video number 1, catchily titled The Mole, from AQA specification. This is topic 3, it's called 4.3, but they all start with 4, and the whole topic is quantitative chemistry. The specifics in this video are 4.3.2.1, which is higher tier only, although there is one bit at the very end that is for all papers, triple or combined, higher or foundation. Right, what is a mole? A mole is a number with a name, and it's as simple as that. You all have come across the words a couple and a dozen before. Hopefully you can all do these before I write them down. A couple means that you get 2 of something. A dozen, you've got 12 of them. If you have a couple of cars, you've got 2 cars. If you have a dozen cars, you've got 12 of them. If you have a mole, it's a slightly bigger number, and this is one that you must learn. It's 6.02 times 10 to the 23, or 60,000 million million million. It's a huge number, and it's a specific number that gets given a name. So if you happen to have a mole of cars, you would have 6.02 times 10 to the 23 of them. That's quite a few cars. So why should we care? Well, it's all to do with carbon-12. This is the atom that everything gets defined against. This is the one that's what's called the reference. If you had 1 mole of carbon-12 atoms, as in you have 6.02 times 10 to the 23 carbon-12 atoms, then that would have a mass of exactly 12 grams. So the whole point here is it takes the number that is the mass of the thing you've got, and it tells you how many atoms are in that same number, but in grams. It's simply a way of converting from the mass that we see in the periodic table, you get this answer given to you in the exam, to the mass that we might actually be able to measure out if we were to do an experiment. And it works for every single element. It's really simple. Here are 4 elements that I picked at random from the periodic table. Remember, you get this in the exam. Oxygen has a mass of 16. Every atom of oxygen has a mass of 16. Every carbon has a mass of 12. Every fluorine has a mass of 19. And every magnesium has a mass of 24. Please ignore isotopes for the moment. So basically, I'm simplifying it down. These numbers are atomic mass units, because atoms are really tiny. We can't ever really just get one atom. What we have to do is measure, well, millions of them at a time. And this mole is just the way that it turns things from being tiny and complicated into simple. If you have 16 grams of oxygen, 16, there's that number 16, then simply put, you've got 1 mole, if I can write the letter M, you've got 1 mole of oxygen. What that means is that you've got 6.02 times 10 to the 23 atoms. We've already seen if you've got 12 grams of carbon, then you've got 6.02 times 10 to the 23 atoms. So the oxygen atoms are a wee bit heavier, and that's why 1 mole of them is 16 grams, whereas the carbon ones are a little bit lighter. That same number of atoms weighs less. And so this is the number that just takes the one you're given in the periodic table and turns it into grams. So if you just remember that, you look, oh, fluorine is 19, so 19 grams, I've got 1 mole. Magnesium is 24, so 24 grams, I've got 1 mole, but what 1 mole means is 6.02 times 10 to the 23. They are interchangeable. 1 mole means that. The good news is it works the other way round as well. So you might get a question in an exam, what is the mass of 1 mole of, and then here are 3 elements that I've picked at random. If you want, pause this and look them up and try them yourselves. So you look up, calcium's number in the periodic table is 40, so 1 mole is 40 grams. Again, if you want to try the other 2. So lithium is 7, so 7 grams would mean you've got 1 mole of lithium. As in, you've got 6.02 times 10 to the 23 atoms of silver. Silver? Where's that come from? Lithium. Now, you might be really, really lucky and someone gifts you 1 mole of gold. We look it up. The mass of 1 is 197 atomic mass units, so therefore to have 1 mole, you have 197 grams. Big, heavy atoms means that 1 mole weighs or has a greater mass than it does for these smaller atoms. So, what about compounds or molecules? Right, so here are 3 molecules to start. Don't know why I wrote oxygen already. We'll just go with it. Hydrogen, we look it up. It's 1 and 1. Oxygen has a mass of 16, and we're only looking at the mass, so we're not worried about the atomic number just now. H2 means there are 2 hydrogen atoms in the molecule. So it's simply 2 times 1, 2 grams. The 1 came from there, there's 2 of them. O2, the oxygen that we breathe. 2 of them. The mass of each is 16. So 1 mole of O2 is 32 grams. And you would have 2 moles of atoms in there, because there's 2 atoms in every molecule. There's another molecule, it's called ozone. It's the thing in the ozone layer, and it simply means there's 3 oxygen atoms stuck together. So we do 3 times 16, and we discover that that would have a mass of 48 grams to get 1 mole. It's the same number of molecules, but because each molecule's got an extra atom, that's why it's heavier. And we can try putting these together if we want to. Here's hydrogen and oxygen. Again, if you want to pause and try them yourself, go for it. So, 2 hydrogens. The 2 is only ever the 1 to the left, so that's 2 times 1. We've been lazy because we're chemists. We don't like the number 1. If there's no number, it means 1. So it's 2 times 1 for the mass of hydrogen, and 1 times 16, so that equals 18 grams. H2O2 is hydrogen peroxide. This one has 2 hydrogens and 2 oxygens. So we put all that together, 32 and 2 is 34 grams. One final one then to try, carbon dioxide. Carbon, as we saw earlier, is 12. There's no number there, so it means 1. 1 times 12 plus 2 times 16, 32 plus 12 is 44 grams. And that's it. It really is that simple. Quick note, these masses you have to be able to do for all papers, but without being asked to work out the grams. But hopefully what you can see here is doing the bit about moles isn't really any harder. Thanks.